Okay, in this problem, we want to determine if the vector field is conservative. And in order to do so, it has to be a continuous partial derivative, and also the curl f must equal 0. And if it does, then it's going to be conservative. And so the first thing we want to do is identify our curl. So we'll use this method. Since this method is mostly like memorization, this is more intuitive. So let's get started. We can say curl f is equal to, so it's going to be first row is going to be I, J, and K. And the next row will be the partial derivative in terms of x, then a partial derivative in terms of y, and then a partial derivative in terms of z. And our p term will be y squared z cubed, so y squared z cubed. And our q will be 2xy z cubed. And our r would be 3xy squared z squared. And so now what we have is like similar to a 3x3 determinant. And so we will need to kind of separate it out. So we'll do I, and then we go diagonally to the right, and we draw a box. And these four elements are in our box. So we have a partial derivative in terms of y. Then below, it's 2xy z cubed. Then we have the partial derivative in terms of z. And below it is going to be a 3xy squared z squared. Then we do I, it's going to be positive I minus j positive k. It alternates between positive and negative. So we have negative j. The thing about doing j, if you go diagonally to the right, you only have two elements or two terms. So we go left, these two, and then we go right, these two. So left is going to be the partial derivative in terms of x, and below was y squared z cubed. And then we go right, so we have the partial derivative in terms of z, and below it was 3x y squared z squared. And then we do k, so we can say plus k. And if you go right, we have no elements, no terms. So we go diagonally to the left, and this is our box, these four terms. So we have a partial derivative in terms of x, partial derivative in terms of y, and what was below? We had y squared z cubed, and 2xy z cubed. So now what we're going to do is like a 2x2 determinant, which is simply like a cross. So it's going to be this term times this term minus this term times this term. So minus this term times this. And it's going to be the same for the other two. So this and this, and this and this, and minus the two diagonal. So this and this. So let's do that. So what we're going to have is I. Now the partial derivative of y for 3x y squared z squared would be 6xy z squared, since we're just focusing on the variable y. The rest we're treating as constants, minus the partial derivative of this in terms of z. So we would get 6xy z cubed. Then we do minus j. We do the exact same thing. So partial derivative of this in terms of x, and we would get 3y squared z squared minus partial derivative of this in terms of z. So we get 3y squared z squared. Then we go plus k. And so we do the partial derivative of this in terms of x. And so we would get we would get 2yz cubed minus partial derivative of this in terms of y. So we would get 2yz cubed. And so what we get here is 0, 0, 0. And so the curl is 0. And it's going to be continuous. The things that are not going to be continuous are like sine x, cosine x. So it's continuous and the curl is 0. So therefore it's going to be conservative. So we can say yes, vector field is conservative. And that's how we prove it. And that's all we need to do.